The total surface area of the cylinder is 884 pi centimeters squared. Find the radius and the height of the cylinder. Okay, so our radius here is this expression 2x plus 1, and then the 4x minus 3, that algebraic expression is our height. So I'm going to start by, hey, this is total surface area. So I'm going to write down the total surface area formula for a cylinder, which is 2 pi RH, there's the lateral part, plus 2 pi r squared for the two circular bases. And now all of this has to be equal to this 884 pi square centimeters for our total surface area. So our algebraic equation that we're going to have to solve for x is 884 pi, there's the total surface area, is equal to 2 pi times my radius, which is 2x plus 1, times my height, which is 4x minus 3, plus, now we've got to put on our two bases, 2 pi times 2x plus 1 squared. All right, so halfway in the door, now I just have to simplify this equation. I've got to solve this thing for x. Before I do, notice that everything here has a pi in it. Each one of these terms here, each one of these terms, the ones that are being multiplied, have a 2 pi in common. 2 pi obviously on the right-hand side for each of these terms, and then 884 because it's even and it has a pi attached to it. So we're going to divide everything by 2 pi's, which should make all of our numbers just a little bit easier to work with. So 884 divided by 2 is going to give us 442. Pi's are gone. All of these 2 pi's, of course, are going to disappear, leaving us with 2x plus 1 times 4x minus 3, and then we have our 2x plus 1 squared. Okay, so what we're going to have to do here is, on the first set of parentheses, we're going to have to FOIL. And on the second one, we're going to FOIL. We're going to expand this out as 2x plus 1 times 2x plus 1. It's a very common mistake that students want to take and distribute this power through that set of parentheses and just square that first term and the last term. Problem with that is that you miss out on a middle term if you try to do that. That's not an algebraic property that you can use here. All right, so I'm going to bring this down here so I can have a little bit more room. What number is this, 30? Okay. So we've got 442. Let's copy the problem down one more time. 2x plus 1, 4x minus 3, 2x plus 1 squared. All right, bring down the 442, and now let's FOIL out this first set of parentheses. 2x times 4x, the first term, so that's 8x squared. 2x times negative 3 gives us a negative 6x. 1 times 4x, a 4x, and then finally 1 times negative 3 gives us minus 3. Okay, again, back up here, we're going to expand out the 2x plus 1 squared as 2x plus 1 times 2x plus 1. First terms are going to be a 4x squared plus, we've got 2x times 1. Oops. We got a 2x. 1 times 2x, we got another 2x, and then finally 1 times 1 gives us 1. All right, so we got to combine some like terms, simplify this out just a little bit more here. Let's bring down the 442, and then our quadratic terms, we've got 8x and 4x squared gives us 12x squareds. Negative 6x plus 4x is 2x's, plus these other 4x x, right? So that's 8 minus 6 is a plus 2x. And then finally, our constant negative 3 plus 1 is a minus 2. Okay, so notice that everything here is even. All our numbers are even, which means if we divide everything by 2, numbers are going to be smaller, a bit easier to work with. So 442 divided by 2 gives us 221 is equal to 6x squared plus x minus 1. Okay, notice that this is a quadratic equation. It's quadratic because we have ourselves an x squared term. So this quadratic equation you don't solve quadratic equations like you solve linear equations. You're not going to get x by itself. First step is to get this 221 over here to the right-hand side. We need to make this thing equal to 0. So 6x squared plus x, and then minus 222 after I subtract it over. Okay, so now what are the ways, after we make it equal to 0, what are the ways that we can solve a quadratic equation? We've got graphing. On a graphing calculator, you can type in under y1, 6x squared plus x minus 222, and you're looking to see where that would cross the x-axis, where y would be equal to 0. That would be one way to do it. We also have the quadratic formula. What's the quadratic formula, you ask? Negative b plus or minus the square root of b squared minus 4ac all over 2a. If we chose to do that, our a is 6, our b is 1, and our c is negative 222. However, I want us to get some more practice using this third method of factoring. Yay. Wait, you know what it needs? It needs a heart. There we go. All right, so we're going to practice doing our factoring. And the factoring as a process is foiling backwards. Okay, so I'm going to open up a set of parentheses here, 2 sets of parentheses, and work this whole process backwards. What we just did when we expanded out these terms, going to work that process backwards. So if we take a look back up here, let's use this blue, back up here at this 8x squared, the 8x squared came from 2x times 4x. It came from the product of the first terms. Likewise, whenever I multiply these two first terms together, I should get 6x squared. In other words, I'm trying to find two things that multiply together to get 6x squared. And you've got a couple of options. You've got 6x and x, or you've got 3x and 2x. So we've got a couple of things that we could possibly choose for that spot. All right, and now for the last terms, if I take a look at this negative 3 that's up here from when we FOILed this thing out, the negative 3 came from 1 times negative 3. It came from the product of our last terms. In other words, this times that should equal negative 222. For right now, let's ignore the negative sign and just focus on the number 222. And in order to try to factor it, I'm going to make a factor tree here. So obviously 2 goes into it 111 times. Now I've got to factor this 111, and notice that 1 plus 1 plus 1, the digits total up to 3, which means that this number is divisible by 3. 3 is going to go into it. 3 goes into 11 3 times with 2 left over, and then 3 goes into 21 7 times. All right, some strategies here. We do have a minus 222, which means that our signs are going to be different. Okay, and then also notice that we've got this middle term here of just 1x. The middle term if I come back over here, the middle term, this negative 6x plus this 4x, those combined up to make the 2x's. Actually, it wasn't the 2x. It would actually be negative 2x's from that one, yes. It came from the sum of the inside terms plus the outside terms there. I'm going to do the same kind of thing down here. That if I add up the inside terms plus the outside terms, that's got to total up to this 1x that's right here in the middle. So that means they got to be really close together if you're just going to have a difference of 1x. And I know it's going to be a difference because we just said the signs have to be different. They're going to add up to a negative number. Now, when I'm looking at my factors, I'm going to notice I've got this 37. This 37 is the key. 37, if I look at this 6 from the 6x's, the blue 6x's, and if I combine up these two factors on the 222, that makes a 6. 6 times 6 is 36, and that's 1 away from the 37. And it seems like those are the ones that we're going to use. So let's give that a try. So I'm going to try to use this 6x times x, and whenever I multiply 6x times x, I get my 6x squared from that original quadratic. And now I'm going to choose to use the factors 6 and 37 for the 222. But I got to be careful where I put these things. I can't put the 6 in this first set of parentheses. If I did, this first set of parentheses would have a common factor of 6, which would mean that this original quadratic equation also has a common factor of 6, which it doesn't because the middle term is not divisible by 6. So let me back that up and pretend that didn't happen. And instead, if 6 is going to work, it's got to go in this second set of parentheses, which leaves the 37 over here in this first set of parentheses. And now let's finish out our foiling. Our inside terms are 37x. And our outside terms, 6 times 6 gives us 36x's. And if we subtract them, we'll get that 1x. Since it's a positive, that means our bigger number, 37, has to be positive, which makes us 37 positive. And our smaller number has to be negative, 36 is negative. To get that negative 36, which means that the second 6 here has to be negative. All right, so we have factored this thing out completely. Now we have to apply the zero product property. Which goes like this. Hey, I've got two things that multiply together to give us 0, which means that maybe A, that first thing, is 0, or maybe B is 0, or, it could be both of them. What that means for quadratics is that you're supposed to take both of these factors, like 6x plus 37, and set it equal to 0. I'm going to solve that small little linear equation by subtracting over the 37, and then divide both sides by 6. I get negative 37 over 6, which, if you prefer, is negative 1/6 and 1/6. Nice. Okay. Or possibly it's the second factor over here, which is x minus 6 equals 0. Add over our 6, and we get x is equal to 6. So quadratics, we should always expect to get two answers, like so. So the algebra part of this is done, but then we have to go back to the fact this is actually a geometric question. On this geometric question, we're talking about lengths of things, and these lengths of things have to be positive. If I take this negative 1/6 and 1/6 and put it in here for this radius, it's going to make the whole thing negative, which doesn't make any sense, so we're just going to get rid of that one. This answer here, even though we did all of the math correctly, doesn't work in the original problem, and we call that answer extraneous. Which means that 6 is our only possible choice. We're still going to double check to make sure that this actually works. So let's figure out what our radius and our height are supposed to be if x is equal to 6. So I believe that the radius was 2x plus 1, yes. So 2 times 6, there's 12, plus 1 more gives us 13. 13 somethings centimeters. Yep. All right, and then our height was 4x minus 3. Double check that. 4x minus 3, okay. We got 4 times our x value is 6. There's 24. Minus 3 is 21 centimeters. We're going to double check it by maybe drawing a cylinder here. That's perfect. All right, and our radius, wait, I'm going to color this. Really make it pop. Really make this base stand out. Excellent. All right, we said that this radius is 13 and this height is 21. So if we put all of this stuff together, remember that the surface area was supposed to be 884 pi centimeters squared. If we plug our new numbers, our 13 and our 21, into our formula, we would get 2 pi times our radius, which is 13, times our height, 21, plus 2 pi times the radius squared for the two bases. And then mashing all of these numbers into the calculator, we do in fact get this 884 pi square centimeters, which means that we did our work correctly. And it means that the radius is 13 centimeters and our height is equal to 21 centimeters. And we're done.